Tapping this icon on your screen will open the AIR TYMR home screen like this. Okay, now let's describe the E6B heading, drift, wind correction, and ground speed calculator features. Again, open your Crosswind Calculator. For a good example, set the runway slider to 03, which represents 030 degrees magnetic. Then set the wind direction slider to 060 degrees and the wind speed slider to 20 knots. Tap the airspeed window on the left side of the window graphic and enter an airspeed of 100. Then tap the blue Done button to dismiss the keyboard. Several things have changed here on your screen. The crosswind and headwind windows and limit windows with switches have all disappeared. In their place are a number of windows with display values based on the vector calculations which you would normally have to do by hand using your E6B calculator. Let me explain these windows and their display values. The runway now represents your desired magnetic heading. This is determined from your map course, then corrected for magnetic deviation for this map sector. The runway label has been replaced by a heading label, and the resolution has increased to 3 digits or 1 degree. The cyan colored windows on the upper left represent drift values for steer angle, ground speed, and course that will result if you steer the actual heading of 030s with the existing winds. The yellow colored windows beside them represent the actual values for steer angle, ground speed, and course that are required to track to the heading to the correct destination. In this example, the steer angle is 35.7 degrees or a wind correction angle of 5.7 degrees to the right to compensate for wind. Your ground speed will be 82.2 knots and your actual course will be the desired heading of 30 degrees with no drift. Now tap the green distance window and enter 150. And tap the blue Done button to dismiss the keyboard. This represents a distance of 150 nautical miles and a flight time is instantly calculated to be 1.83 hours. This represents 1 hour and 49 minutes of flight time based on the actual calculated ground speed of 82.2 knots. These windows are dynamically calculated, so you can adjust the heading, the wind speed, the wind direction sliders for new values, and the calculations will be done automatically on the fly, so to speak. Try it yourself by setting the heading to 60 degrees. It is well known that sliders are quite touchy when the slider resolution is high, so you can simply get close to 60 degrees and use the plus and minus buttons at the end of the heading sliders to increment and decrement the actual value by 1 degree for precise settings, like this. These buttons disappear in the runway mode since the resolution is much smaller and are no longer needed. Now look at the values on the left. Since the wind is directly on the nose of the aircraft, there is no drift. Both the drift calculations in the cyan and the drift corrected calculations in the yellow give the same results as expected. The ground speed for both modes is simply your airspeed minus the wind speed, since this is a headwind. Try setting the heading or the wind direction to other values and watch the windows change dynamically. This is a very powerful and easy to use tool right at your fingertips to estimate headings for your flight. Enjoy the benefits of this simplicity. On the upper right hand corner of the screen, tap the green pressure altitude window and enter 8,000 and tap the blue Done button to dismiss the keyboard. This represents a pressure altitude of 8,000 feet. Notice that the outside air temperature, or OAT window, has turned green, ready for input. Remember, the pressure altitude is simply the altimeter reading when you set the altimeter to 29.92 inches based on the standard atmosphere. Tap the outside air temperature window and enter 12, and tap the blue Done button to dismiss the keyboard. The density altitude window will turn yellow, and it will display a value of 9,564 feet. This also would normally be determined by hand using an E6B calculator shown here. On the E6B, you simply align your pressure altitude with your outside air temperature, and you read your density altitude here. And here it shows 9,500. If you enter a value of 0 in the pressure altitude window, like this section will reset and be ready for new values. Similarly, if you enter a value of 0 in the airspeed window, like this, the E6B mode will clear and the graphic window will return to the runway calculator mode for crosswinds. Well, that's it for the E6B. Now you're ready to learn about the flight timer, so check out my Part 3 video.